Hi there, my name is Aaron Lanterman. I'm a professor of electrical and computer engineering at Georgia Tech, and this is sort of a little general template I created to start laying out synthesizer-related PCBs. I've set this up so that this will fit into the community version of Eagle, that board size. Of course, you might need to expand it, set some, what did I do here? Let's say I set some drill sizes here. I think this is 3.2 millimeters for holes, mounting holes on the sides. Anyway, I'm just going to sort of blast into this. I'm going to post this entirely unedited. If you're looking for anything educational or entertaining, you probably want to go somewhere else. I'll just kind of talk out loud as I'm doing this. Let's see. Let's switch back to the schematic. I'm going to be laying out the phase shifter from the output circuitry from the Buchla 360 programmable octal signal source. And so Buchla used plus minus 15 volt supplies for things like that. So I'm going to get rid of all of the Eurorack stuff. Group. Trash. Now I should be able to option, or is it control click? Oh, delete group. There we go. That's what I want. Delete group. All right. So we'll just stick with using the 15 volt supplies over here. That's what I want. Do. Let's see. Okay. So I'm going to need a bunch of TLO 72 style op amps. Actually, I'm going to need a bunch of TLO 74s. Move group. Okay. So I want to control click. There we go. Okay, move all that up there. Anyway, let me add a TLO 74 because we're definitely going to, let's see, there's this music theme modular library. Let's go ahead and just use the one that's built into Eagle. We don't want to use the surface mount one. We want the P version. All right, so I'll have, see, this will be for the output circuitry. So I'll have op amp, and let's zoom out here a bit. Op amp. Oh, I should have moved this first. Now, I'm rotating all of these. Let me mirror. Because what I want to do is I want to have the feedback loop above here. So let's see. I'll also have a bunch of resistors that are coming into it. So let me add, actually let me copy because I want to have a bunch of input resistors here going to the negative terminal. And actually each of these, do they all have three? Anyway, they have at least one. So I'm going to definitely put one here, one here, one here, one here, and then we need the resistors that go in the feedback loop. So let me put, I'm going to try to match up the original schematic a bit. I'll put this one here, put this one here, put this one here, put this one here. All right. Okay, so let's add some capacitors. I have this Aaron capacitor symbol that I like, that I made that was custom. And the reason I like that is that, let's go to the board. The built-in Eagle, here it is. The built-in Eagle symbol has a little capacitor symbol here inside the outline. I like to put the capacitance there, so I made like my own little custom library that did that. All right. Back to the schematic. So we'll put these capacitors in the feedback loops. Let's see, we'll put one here, put one here, put one here. Okay. Have to click on the plus symbol there. Oh, well, all of the little symbols, they have a little anchor point they have to click on. Like this plus here is the anchor point for the value, but not the symbol. So if you want to change the value, you have to do it there. And let's go ahead and do that. These are all supposed to be 10K 1% resistors. So I'll go 10K 1%. 10K 1%. Notice I have to click on the middle of the resistor symbol, not up here where you see the 150K as sort of my default, because you're changing the value of the resistor. So this is 10K 1%, 10K 1%. All right, let's add some grounds. So the positive terminal here is grounded on all of these. And I tend to like, I'll vary a lot in how I do this. Whoop, that wasn't what I meant to do. Here we go. Let's see, this ground. You can put the grounds directly on here like this, but I tend to like to separate them a bit just because I really like to see a bit of green there to indicate that these things are connected. All right. Ground, 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 good ground, good ground. Let's do value. Oh, wait, we already did value. Let's name. So this resistor is R1. Oh, it already exists. Okay, I'm going to do a trick I would call R1A. And then, where's the other one we called R1? Where are you? Oh, this one. Well, this one, oh, actually, so this one is, we'll call this R12A. And we'll call this one here nope, that's the capacitor. So this one's R1. And then the next one is R8. R8 already exists. Where's R8? No, this one down here is not R8. This one is R19. This one's going to be R13. Whoop, that was the capacitor. This is R13. And then the one here, we can now make R8. All right. So I see, okay, so those are the op amps associated with the output circuitry. And let's see, the capacitors are all, what are the capacitors? The capacitors are 100 picofarad. So let's type value. And notice I'm typing into the thing, the little command line up here. I find that actually faster for me at this point than going over here and clicking on the symbol. That's basically, sorry, it's 3:55 a.m. That's basically clicking icons over here is equivalent to typing things up here. Okay, so this is going to be, the new value is 100p, 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 100p. Whoop. Should probably have done this by making one of these and then cutting and pasting. Okay, value. No, not value. Name. Let's see. So this, we'll call this C1, 2, 3, and 4. So I got C1. Whoop. Okay, it already exists. Okay, great. Let's change this to something else, then call it C100. We'll come back to that. All right. So this is C1, C2. Gah. Let's see, C2A. Or to be consistent, let's call this C101, sure. Okay, now this is C2. And now this is C3. Now this is C4. All right. So those are all named accordingly. The input resistors here are a big complicated tangle, so I don't feel like dealing with those right at the moment. One thing that does happen is that, oh wait, actually, did I have this wrong? Oh, no. I was looking at the wrong part of the schematic. These are not, that's part of the big tangle. These are not actually grounded. So let me get rid of those. That's a different set. I was looking at the wrong part of the schematic when I thought of that. All right, so that's op amp 1. Let's add TL070P, I think it is. Okay, so this is going to be a set of phase shift thingamadoobers. And yeah, okay. So let's do this. We'll have, let's put some space here. We'll put one here, and then one here, and then one here, and then, wait a minute, these are TL072s. That's not what I want. I want TL074s. That's what I want. All right, so I'll have op amp here, op amp here, op amp down here, and then an op amp over here. All right, and now let me, oh, I do want to do the thing of, let's see, I want to have the negative on top. Why didn't they just do that? Because I have to rotate, whoop, no, not mirror, not mirror twice, mirror once, and then to rotate. All right, there we go. Now we've got all that rotated. Okay, so all of these have some resistors that are going to ground coming off of the positive terminal. So let me put those in. And these are all, oh no, they're slightly different. Okay. So the ones up here, those two are 33K. And actually, let me put in the other op amps here. So let's see. Let's do a copy. So this should come up as 3. Oh, that's creating a whole new op amp, so I don't want that. So what I really want to do is, let's say, invoke. So I can get the next one. A, B, C. I'll move this down here. Okay, so I have those kind of lined up. All right. Actually, you know what? Let's experiment here a bit. Let's see, I should be able to control click on this and delete group. Okay. Let me copy these resistors again. So I'll have resistor here, resistor here. Let's see, net to draw some lines in here. All right. Now I'll copy the ground. Actually, let me delete the ground from here. We know it's ground, right? So let's copy this ground to here, this ground to here. I made a big deal earlier, or at least a medium deal, about liking to see some green to know these things are connected. But here I won't. All right. Now there's resistors in the feedback loops of all of these. Resistor. That's a little too high. Let's bring these down then, so it doesn't bump into things. All right. And then there's sort of a kind of a, the way it's drawn is there's another set of resistors in between here. So let's put a resistor here. Then I'll put one here. Put one maybe okay, there's the feedback, the connector resistor, feedback, and this connector resistor. How about something like this? Maybe let's move all this over just one. Control click, move group. Because what I want to do is now move this guy over here and leave that one there. Okay, whoop. No, all right, let me pull out my net tool. Let's connect some things, making connections with this little green wire thing. Okay, and there's that feedback loop connected. Same thing here, making connections. Okay, and then going through, let's see, and these are all 10K resistors. I should have changed the value of the resistor first to 10K, so I wouldn't have to do this for everything. That's what I should have done. Let's copy another one of these guys here. All right. Let's see, there's some capacitors. So we'll grab a capacitor up here, control click to rotate, put one there, stick one down here. Copy. All right. Let me do the thing. Oh, these are different values though. And some of the resistors down here are different values too. That's interesting. So I'm not going to worry about values for the second because they do change. All right. Then okay. Like that. And then let me connect this using the net tool. Connect, 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 connect. Is that pretty? Not really, but oh well. Usually I'd want to see some more green here coming out of that node, but whatever. All right, let's see. So, let's see. Name, this will be R45, R46, R47, R48. Okay, and then along the top, we are going to have name R30, R31, R32, R33. Okay, and what about the capacitors? This guy here is C7. Where are you? Where are you, C7? There's an existing C7 already. Where are you? Show C7. Move C7. There you are. Okay. Well, you're not really C7 though. You are C8. Although it's probably going to... Actually, let me start down here. So this one is C14. This one's C13. C13. This is C8. If you're watching this, hi. I have no idea why you're watching this, but thanks for hanging out. Okay, so let's see. We've named the resistors, what they are. They've all got the appropriate values. Oh, let's name these resistors to ground. This one's R11. This one's R10. This one's R70. This one sort of logically would be R69, I guess, but it looks like R68 actually. I'm going to put a question mark on that. And let's look at the values here. So let's see, this resistor is 33K. This resistor is 33K. This resistor here is 47K. And this resistor here is 33K. And let's see, the capacitor here, this one is mu01, or I'll say 0 mu01. So that's 0.01. I'm using mu in place of the decimal point. So this is 0 mu022. This one is 0 mu1. This one is 0 mu01. So the capacitors here are different. All right, so let's see what happens. I'm going to group this whole structure. Okay, we've grouped that whole structure. And now I'm going to try to copy the whole structure. I'm going to control-click down to copy group. All right, so that's copy the whole structure. And let's see, how do these generally connect to one another? Okay, I sort of did it like that. All right, and so that made a IC3, so that's great. Let's see, coming into this, okay, so the first branch here, the first set here, this doesn't have this little network on the positive terminal. These guys here just go to ground on the first one. Yes, connected to ground. All right. Let me connect these up. Okay. Now, what about these capacitors? Okay, so this one here, this capacitor is of value 0 mu001. The one down here is a value 0 mu0047. Let's see. This one is still 33K. This one, though, whoop. This value, I don't know what happened there, is 39K. And let's handle names. So this resistor is R71. This one is R9. R9 already exists. Great. Where are you? Show R9. Move R9. There you go. Okay. Let's then just change going outward that direction. So this is R34, R35, R36, R37, and let's see, and in the denominator here. No, in the, okay, so this is R49, the lower part here. R49, R50, R51, R52. Okay. And, let me connect this here. All right, so that's connected through. Let's see. Oh, I want to be careful though with the, oh, wait a minute. I did something untoward there with the values. Oh, I got my name and values mixed up. Shoot. Okay, this one's R34. This one's R35. This one's R36. And this one's R37. Okay, let me fix the values. This is 10K, 1%. 10K, 1. I should indicate that these are all 1%. 10K, 1%. 10K, 1%. 10K, 1%. I could stream this on Twitch, and I could have the world's most boring possible Twitch stream. Live stream, watch Aaron Lanterman say 10K 1%, 10K 1%, 10K 1% over and over. Maybe we could have like Liam Neeson or Morgan Freeman to do that. Oh wait, this one is actually different. This is not 10K, this is 20K. This one's 20K. And then the rest of them are 10K. Right. And, oh, okay. So now I need to think about what else is coming into the minus. This is confusing. So there's actually two 20K resistors going into the minus terminal. So this is part of this weird 8 signals to a quad output with weird mixing phase shifting stuff going on. Let's see. Okay. So there's two 20K resistors attached to each of those. Let's fix the names. This one is R26 and this one is R27. Make sure this one's R52. This one is R51. This one is R50. And this one is R49. All right. Now, coming in from the previous set of op amps, let's draw it like this. So the top here goes all the way down and connects to this bottom resistance. And these two inner resistances here connect. And there's a connection out here that will just leave open for now. And then up here, there's a connection coming from out here. All right. Let's connect that. Okay, does that all look connected? That all looks connected. And then there's a complicated network of stuff coming out of here and going to other places and blah, 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 blah. But before I do anything else, I want to get a sense of how the layout of this particular structure looks. So I'm actually going to switch over to the board layer. Okay, so let's move IC2, which goes here. And let's move IC3. We'll put that here. How close? Let's put in some spacing here. All right, so what I'm going to do is I'm going to look at my schematic, which is elsewhere. Let's see. I'll switch in between. Generate, switch to board. And what I'm going to do is I'm going to schematic. There we go. So now I have the schematic. So I'm going to pull this off of the screen capture space. But what I'm essentially going to do is I'm going to type move R30, move R31, and try to figure out the best placement for these things. So for the feedback resistor, I'm probably going to have that come out of pin 1, say, and then whatever's hooking to pin 2, that I'll have, or this sort of connector resistor, this input resistor, I'll have that hooked to pin 2, and then I'll probably then have this this resistor here, like this R10, hooked to pin 3, and then I don't know. We'll see what I feel like doing. All right. So first, let me put in all the feedback resistor. So I'm going to say move R30. That's a feedback resistor. I'll put that here. Yeah. Okay. Let's move R32. Do the rat's nest. Let's see. That's the feedback resistor. I'll put that here. Let's move R45. Put that resistor there. Let's move R47. Put the feedback resistor there. Okay. Now let's move R31. This is that input resistor. And this is actually, okay, so this resistor is kind of connecting. It's kind of connecting these things. Actually, let me put that off to the side for a second. Let me first place those resistors to ground. So I'll put move R10. Okay, I'll put them here. Move R11. Put that there. Notice I'm being careful to spin it around so it's connecting right. So, because I don't want it to do something like, whoop. I don't want this, at least right now. Okay, the other ground resistors have an R70, and then I have an R68 question mark, I called it. I really want to call that 69, but it looks like 68 on the schematic, on the original schematic, so I'll put that there. Okay. Okay, now I have these little connector sections that go between them, and let's see. Let me do that for the same sort of thing for IC3. So let me move R34. There we go. Let me move R49. Constantly typing rats to do the rat's nest. Move R51. Let's put that. No. Rats to indicate what's close. Okay, I'll put that there. Move R. Wait, which one did I just move? That wasn't quite doing. Okay. So that was show R49. And I'm doing the feedback. Okay. Move R50. Wait, what am I doing? Okay. Sorry. I just confused myself. Move R51. Do I like where that is? Okay. I like where that is. Yeah. Let's put that there. Move R36. Okay. So I'll put that there. No, I don't want to put that there. Right, I want to have the feedback coming out of there. Okay, and let me do the same thing with the ground resistors. And I only have a couple of them here. So I have R71 rats to see where it connects. Okay, so that's going to connect. Wait, I don't want to confuse myself. Ground. Right, okay. What the ground resistor here is, it's connecting to this pin here. That's really what I want. Do show ground to make sure I'm doing something sensible. Okay. And the other one I marked, I don't think I changed the value. So the value on this one is, it's just R9. R11, R9. Okay. Yeah, R9, R10, R11. There's not necessarily totally logical. Whoa, I didn't mean to do that. Just, right. There we go. Okay, so let me go ahead and move that R9. Whoop. What do you mean you don't know about R9? I just saw it. Oh, I don't think, should be R9, but here I think it's R5. So name, let me change this to R9. All right. Move R9. Okay. That should go here. Let me do show ground. Look at the structure. All right. Okay, so let's see. I've got space in here and I do want to use it. So let's see. This R31, so this is kind of connecting the various stages. Along with this C2, it's sort of a connector. So let's move R31. What I'm going to do is I'm going to put the... Right, okay, so it's coming out of there. No, okay. So I'm going to have it on this side here connected to the negative terminal. That's what I want to do. All right. And then, so the other connector resistors are 46. I was thinking I could put it up here, but I just want to use up the space. I want to really I need to try to make this compact. Okay, so that was R31. Let me do the same thing with R46. No, not down in the schematic. Move R46. Okay, let me flip. Okay, got that. There you go. All right, so the other, I've got R11 and R70. Oh, wait, no. That wasn't what I wanted. Oh, it's R33 and R48. Move R33. Coming out of the negative terminal. Okay, move R48. Wait, did I have the right one here? R48 should connect to pin 9 on this one. No, not move R8. Move R48. Rats. Ah, there we go. Okay. Now that's connecting to the negative. Okay. And yeah, there's going to be some crisscrossing here, but that's inevitable. Let's see. So let me move R9 and R71. I'll do the same thing. Move R9. Oh, wait. Not R9. We already did that. I want these connector ones. So that's R35 and R50. Move R35. Move R50. Let's do rats to make sure this is connecting where I want. Ah, there we go. Okay, so that's coming. That's going to the negative terminal, which is what I want. Okay. And then there's these other connecting resistors I've got. What are you? Info. You are R37. Because there's two of them coming in here, right? So there's an R37 and R37 and an R26. Move R37. And I'll move an move R26. Actually, do I like this? I'm going to put those off to the side for a second. Let's see. And then I've got the capacitors I need to put in here. So there's I should put in some bypass caps before I'm tempted. Really need bypass capacitors. Okay, so I'm going to go over here. Let's actually group all of this here. Group. Move, control click, move group. I think newer versions of Eagle have newer, nicer ways of doing things. I'm just used to older, not as nice versions of Eagle. Yeah, let me copy. We need some bypass capacitors. Okay. What do you mean? Okay, copy. Okay, I'm going to put a capacitor here and a capacitor here. And one here and one here. And one here and one here. Okay, and I'm going to connect all of these up. Do. Now, yes, please merge. Usually want to merge unless you don't want to. Yeah, show ground. Let me do show ground just to see. Okay, so that's show ground, show V plus, show V minus. Okay, so let's call the capacitors, we'll call this C102, C103, C104, C105, C106, C107. And some people would like to create, they'll like to actually have the power pin showing on the op amps and have the bypass capacitors showing with the op amp symbol. I tend to find that confusing. This is just sort of a general circuit hygiene. It's not really associated with the actual reasoning of the circuit. So what I like to do is then invoke. I like to just put those capacitors up here. Okay, so here's the power. I used invoke to get the power for IC1. I'll use it to get the power for IC2. And I'll just plunk them up here and connect them all together. Now there's ways to have Eagle sort of internally handle all this if you name things properly, I think. But I generally mess that up when I try to use it. And I just find it helpful to have these things marked out explicitly. Okay, V plus, V minus. All right. Okay, so let me put in those bypass caps. Let's see. Let's move a C. Let's see. 2 and 3 we'll say for IC1. So we'll say C104. Move C105. Move C106. Move C107. All right. And show ground. Okay, so I'm going to flip all of these around. Doot, 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 doot. Show V plus. Okay, so maybe we'll take this one and put it on IC2. And we'll take, whoop, didn't mean to do whatever I was just doing. All right, then we'll put this one here. All right, C105 I'll put here. Then C107 I'll put here. Okay, show ground, show V plus, show V minus. All right, that seems to make sense. Now let me think a second about that capacitor. Oh, I should say things out loud that are meaningful. All right, where's my schematic? Schematic. So these capacitors see. Okay, so R31, like these resistors connect the positive here, or the output of one op amp to the negative input of another. And these capacitors connect the output of one op amp to the positive terminal. Let me maybe just run the capacitors off to the side. So let's see. Let's move C7. Move C7. Something like that, maybe. Feels like. Well, maybe when I rats it, maybe I'll who knows? I may change my mind about these things. Move C8. Oh, actually, no, that's up. That connects these guys. Oh, wonder if I should put it something in like here. I feel like I want a bit more space. Let me group all of this. Go to move group. Because I don't actually know where I started. Something like that. Maybe. Let's see. And let's see. So that's C8. What was the cousin of C8 is C14. So if I did something like that, I could smush those up together. Nah, let's not get so smushy. Okay, how about something like that? And then, say I have C13. Move C13. How do I want to? Maybe I want to do something like that. There's a lot of, we're just going to have more or less crisscrossing. I don't know. I think there's some possibilities that are just hidden by the current rat's nest, just the way the rat's nest currently appears. So I may think about this. So let's look at, okay, so these guys connect there. These guys connect there. Now, if I were to flip this, does it feel less crisscrossy? Well, there's definitely crisscrossing, but this, having this flow like this somehow feels better to me. I have no idea why. Why does that feel better to me? Anyway, let's see. Then I'll have C5 and C6. And actually, let me see. So this is C13, C14. This should be C15. This one's C7. This is C8. This is C9. Yeah, okay. So let me move C15. So if I do it like this, it feels like I'll have more of a parallel structure. I don't know. I'll probably keep changing my mind. All right. In case you're wondering if there's any logic to what I'm doing, not really. All right, let me move C9. Move C9. Do, 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 do. Then, right. Okay. Now, just to show you how I like to set up the power supply here, let's just go ahead and do that. Let's see. So show V plus. Let's see. Here's my. Oh, let me put in my capacitors. Here's my. Here's my bypass caps. Let's put the bead here. So these inductor beads, I got into the habit of doing this from Paul Schreiber, the creator of the MOTM synthesizer and extremely experienced electronic designer. Let's see. So, okay, so V plus, be over here. Let's see, so V plus is on the, So let me turn this around. Can't remember if Paul sort of has a standard of which way it plugs in here. In any case, I'm just going to go with whatever I personally find convenient at the moment. Maybe we could put it over here. I don't know. Let's see. So I actually looked, and it looks like Paul Schreiber usually has this part of the polarization strip, like this little latch when you put on the connector going the other direction. But if I do it like this, then I have this nice V minus there, and then I have a V minus over here. So I kind of like that. What if, actually, let me grab all of this. What if I just stuck this over here? Yep. I'm going to have to move all of this at some point anyway, probably. But let me put it here for now. Yeah. There we go. Put the bead here. Let's see. So let's show show V minus. Let me flip these around. Do. Show V minus. Okay, I like that. Let's see, show V plus. Need to flip these around. No, come back here. Flip. Flip. Do I like that? Yeah, sure. Show V plus. All right, so that's where I've got my various wires. Let me zoom in here and think about how I would want to place the power supply. So for the power supply, let me try to use yeah, see, it defaults to this 6 mil, which is absurd. This is just an absurdly small trace. So for something like the power traces, let's see if I can get away with. Let's see what I can get away with. So I'm going to, let's see, let's start over here. Okay. Ooh, if I was really picky, I wanted to make that symmetric. Could do something like this. We'll have it come out diagonal. I'm being way too pedantic here. Let's see. Yeah, let me have it come out. Or we'll have it come out sideways here. Oh, but then it goes, okay, let's see. Whoop. If I move this up one. Let's see, how are my grid settings? What if I make the alternate half that? Because the capacitor is kind of at this weird, it kind of has this weird, unusual footprint. Well, it's not weird, it's just the spacing of these guys. Ooh, I like that. Don't you like that? I like that. All right. Let's see. So we'll connect. Yep. Yep. Okay. Then show ground. Let's see. Actually, let me route the power first. Who wants power? Let's see. You want power. And you also want power. And you want power. Let's see. Do. Oh, because I have the little, this is all a little offset, isn't it? If I really wanted to make this more symmetric looking, I could do this. It's not going to be perfect either way. How about that? Let me rip this up. I'm being insanely pedantic here. And I'll have to scooch this over at some point anyway, or move all of this one way. Let's see. Okay, if I did that, then this can come in, right? That goes in one. Okay. Okay, so this goes here. Zoop. Like that. Show V plus. Show V minus. Okay, so things are getting powered. Actually, let's see. So let's use blue. We're going to switch to blue just right here. And the reason is we can eventually run a red trace going through orthogonal to it. Right. Okay, who wants ground? All of these things want ground. I am gonna definitely have to move that over. Let's see. How much chance do I have actually of fitting this whole circuit into the board this small? Not very much, but let me not give up entirely yet. How about, yeah, what I'm going to do is I'm going to group. Let's group a much bigger, let's group all this. Move group. Whoa, I didn't mean to do that with the, oh, and I actually didn't mean to move to do it that much anyway. Yeah, I think that's further out than we really needed. Okay, I didn't mean to do that. But let's just go ahead and okay, so if this is the ground, there's a ground that comes out here. I can get that whole thing closer to the edge. Surely I can. Okay, so I'm going to try to not grab the entire board this time. Oh, is it already grouped? Move, click, move, group. Ah, good grief. That was definitely not what I wanted to have happen. Okay, group. Just group this smaller set. Group just these things. All right, that's what I want grouped. Okay. Now I want to move. Now I do want to move, but let's move just this group. And actually, okay. I betcha I'm going to have to leave some more space in there eventually anyway. So let's go jink, 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 jink. Actually, maybe not that many jinks. Okay. So I can have a little more space in here to run traces. I'll bet you I'll need that later. Okay. So as far as grounds go, we got this. This one can snake behind here. This one can snake. Like that. All right. Do we like that? I think we like that. Who wants grounds? Okay, you want grounds. Wait a minute. I don't think Oh, I was confused about what I was doing. Okay, show the grounds again. Okay, wants grounds here. You want a ground? Notice I'm snaking the ground sort of outside around the edge of the board. You might be able to get something closer through this way, but I've got so much crisscrossy, zigzaggy. I want to try to kind of keep this part of the space clear. Okay. Something like that. Although, There you go. So something along those lines. And wait, this is kind of ugly. What's going on here? All right. That's better. Let's see. This one, I think. Whoop. Show ground. Oh, you do want a ground? Okay. So I have it coming like this. It sort of shows the flow. It's a good visual indicator later of sort of which direction you expect to see the ground in. This is like star grounding. I'm imagining that, you know, ground's coming out of here and then it's sort of spreading out its little tendrils. Okay. Of course, I could have it go kind of like right here. I just grabbed the wrong thing. This is the ground. Could have it come straight out like that, but notice I'm giving this little bend, again, as a visual indication of what the ground is flowing out of. Okay. Let's see. There's going to be some crisscrossy zigzag in here. I'm going to wait to... Actually, well, let me go ahead and do this one. Actually, no. Before connecting further grounds here, let me route some of the signals. And actually, the power, you know what? I bet you I'm going to have to run the power through the middle here. Let's see. All right. So for signals, let's switch to, I usually like to use either 15 or 16. Here I'll use 15. And we'll switch to the blue layer and see what wants to connect to what. Okay. So these are all pretty easy. Doot, 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 doot. I'm going to have to reroute the power here. The power, whoop. Let's see. So for the power, let's switch back to the top layer. Let's go back to 30. And I'm going to have it go here. There, okay. Okay, so show V plus, there we go. Let's rip this out here. Have to have the power going down the middle there so I can use red traces also around the top here. Do. All right, so where's the power? Here's the power. All right. Okay. Actually, do it like that. Oh, wait. I'm redoing it the way I had it before. Derp. Okay. Oh, I do need to move. I am going to need to move those capacitors out. So let's see. There we go. And then this one. There we go. Okay, so now I have the power routed through the middle. I'll move the capacitors out here like this. All right. Okay, so I like that better. Okay, so let's go back to 15 and start routing signals. Whoop, nope, but let's do it on the blue layer, the bottom layer. Okay. Whoop. Okay, so right here. Wow. Let's see if that's where that's going. Is this setup more elegant? Oh, it's going to have to go over there anyway. Da, 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 da. Okay. Okay. Got some symmetry going on here. What do you connect to? Okay. Let's connect these guys. Whoop. All right. Do we like that? Let's see. Let's go ahead and switch to a different layer. Bottom here. We can do that. If we do that anyway, let's rip this up. Let's just go ahead and do this whole thing in red. Okay, let's see. Okay. Then we could put another red here because it will crisscross. Right? I mean, we could have the blue snake around. But I think we might as well do something like this. Okay. So if we do that, then we could do something symmetric kind of down here. something like that. If we want, we could keep going with the red trace just to indicate. So if you look at the PCB later, you'll be able to tell. But if I do that, there is a problem here. Let's see. I do need to get ground into here. That's not a problem up here, though. If I did this, right? Oh, same with here. Okay. Just making sure the power's okay. Right, and now if I switch to the top layer here, let's try to snake this. Whoop. Let's snake this here. No. Top. All right. Why does it keep doing that? Oh, there's already a little bit of blue here. That's why. All right. So we've got top. Okay. Whoop. Oh. For power, let's do this. Right. I like it like that. There we go. Let's see. So there's these capacitors out here. Let me switch back to a 15 line. Okay, so that's consistent. This should be fine, but just in case, I'm going to hold down Shift. That's a little too close either way. I want to kind of put it right in the middle there. So how about, let's make this be 125. There we go. Now that's really in the middle. All right. I like that. Let me put that back to 0.25. Do. And let's see, now we're getting into questions of what to do over here. But let's see, who wants to talk to who here? These need to talk to each other. These need a ground. These guys need to talk to each other. Let me go ahead and snake some grounds through here. Actually, let me do it like this. There we go. Same thing down here. All right. Let's see. Show ground again. Whoop. All right. And if we do this, then we can take this guy and, all right. And let's switch to the other layer for okay. Now we'll probably need to snake some lines through here later, but just for now, what I'm going to do is I'm going to go ahead and make this red so that then if we're looking on that side of the board, it's clear what's connecting to what. There we go, something like that. Okay. Alrighty. So that's, I think, the majority of the connections in that section of the board. No, there is this one here. Okay, well, for this one, we might as well go ahead and let that be blue. So in here, so there's this nice symmetry in that structure. Alrighty. So normally I enter the whole schematic and then I start doing the layout. Here I wanted to just get a sense of the size. I'll be really surprised if I manage to fit the circuit in a board this small, but we'll see how far I can go.